All. This is Dr. Shanthi, Professor, RMK College of Engineering and Technology. Today in this video, we are going to study about the topic of microstrip patch antennas. Now this comes under 4th unit of antennas and wave propagation. Now let us see what is meant by a microstrip patch antenna. In high-performance aircraft, spacecrafts, satellite and missile applications, you require antennas that are of very small size, weight, less cost, ease of installation, and they should also have aerodynamic profile, which means that they should be able to withstand all the climatic constraints. Such antennas are going to be called as low profile antennas, which are required for specific applications. Right, as I told you, low profile antennas are antennas with small height, width, and they do not extend very far from the surface they are mounted on. Such antennas are the best example for low profile antenna is a microstrip patch antenna. Now look at the two figures that are shown here. When I say a microstrip patch antenna, you will have on the upper part, that is when you look at the antenna, on the one side of the antenna, you will have a patch, that is radiating patch. It can be of any shape. There are two diagrams shown in this figure. The first upper half, you have a rectangular patch in the first diagram. And in the case of a second diagram, you have a triangular patch, right? And to the other side, you will have a ground, okay? And this yellow color one, slight greenish one, this is going to be substrate. So in short, if I say, in the case of a microstrip patch antenna, on one side you will have a metallic patch, on the other side you will have a ground, and in between them you're going to have what is called as substrate. Now look at this diagram. This diagram shows a clear view of it. This yellow color one shows the patch, the radiating patch. L is the length of the patch. W is the width of the patch. And this is the dielectric substrate, what we have. And this height H is the height of the dielectric substrate. Then the other side you have what is called as the ground plane. So this is the basic structure of a microstrip patch antenna. Right, now what are the various parameters when you go in for the design of a microstrip antenna is? L is the length of the radiating patch, W is the width of the patch, T is the thickness of the patch. Okay, and this patch can be of any shape as I told you earlier. H is the height of the substrate. This dielectric substrate can also have various dielectric. You can use any substrate whose dielectric constant can vary from 2.2 to 12. And the other side is going to be a ground plane. Now look at this diagram. This diagram shows the top view and the side view of a microstrip patch antenna. Now here you have a microstrip feed. This is the patch. These are your field lines. This is the top view, right? And in the side view, this is going to represent the patch. This is nothing but your substrate, and the other side is going to be a ground plane. Right. Now, microstrip patch antennas consists of a very thin metallic strip, the thickness of the strip being represented as T, and it is very much smaller than the wavelength lambda. And it is placed above the ground, separated by means of a dielectric sheet called the substrate, as I told you earlier. Right. Now, these substrates, their dielectric constants can vary in the range from 2.2 to 12. Thick substrates with dielectric constant of 2.2 are more desirable for good antenna performance. Why? Because they provide better efficiency, larger bandwidth, loosely bound fields for radiation into space. Thin substrates with high dielectric constants are desirable for microwave circuitry because they require tightly bound fields to minimize undesired radiation and coupling and lead to small element sizes. Microstrip antennas with thin substrates have greater losses less efficient, and have relatively smaller bandwidths. So depending upon the application, we have to select whether we require a thick substrate or a thin substrate, or what is the substrate what we are going to use. What is the dielectric constant of the substrate what we are going to use. Now these are the various shapes of a microstrip patch antenna. The patch can be a square patch, a rectangular patch, a patch like this, circular patch, triangular patch, a circular ring, or elliptical patch. So the patches can be of any shape. Now this diagram shows the microstrip antenna arrays. Now look at the diagram. When you see, you have a number of patches placed in the form of an array, and the main objective is that you will get an increased directivity, right? Right now, these are some of the common substrates that are used: honeycomb, duroid, that is duroid. You can use quartz. You can even use alumina. And as I told you, a thicker substrate will increase the radiation power, reduce conductor loss, and improve bandwidth. Now, these are the design equations that are getting involved, or what we use for designing a microstrip patch antenna. What I told you earlier is going to be W. W is nothing but the width of the patch, and L is nothing but the length of the patch. So these two are very important in designing a microstrip patch antenna. And that is FR is nothing but your resonant frequency, and epsilon R is nothing but your dielectric substrate, or its permittivity of your dielectric substrate, right? And C naught is nothing but the speed of the light. Okay. Now coming on to the advantages of microstrip patch antenna, it's lightweight, low volume. Mainly it is a low profile antenna. So that is why it is mainly used in almost all the applications, right? You have patch antennas. Patch antenna finds applications in almost all the devices what we in the that is in the mobiles, mainly in the mobiles what we use. We have small microstrip patch antennas placed. Thank you.